Hello 8th graders, we are going to be doing lesson 4 and 5 in this video. We'll start with lesson 4, square roots on the number line. Our goal is to look a little more closely at square roots, and hopefully this little meme there makes you smile. Here we go. One thing I want to note is that I provided this reference sheet for you on Canvas. If you haven't downloaded it yet, please do so. It's something that will be really helpful in these two lessons. And you could also copy it into your workbook or just print out a copy if you have a printer at home. But one way or another, this is going to be a helpful reference for you. First thing you're going to do on this one is find the exact length of the line segment. I'll help you get started here. Let's create a square from this line segment. This is something we did in lesson 3. And then you'll notice we have a larger square around it. And you can use the method we've been doing to find the area of that square. And then from the area, you should be able to figure out the length of the side. So go ahead and do that and do number 2 and start again when you're ready. So you should have found that the area of the square was 2, which means the side length is going to be the square root of 2. And then decimal approximation, you can follow that circle down to here, and it looks like it's just over 1.4. So we'll call it 1.41. When you're estimating here, 2 decimal places is fine. You can stop there. Okay, we have another slanted line, and we're going to estimate, we're going to first estimate the length of the line, and then we're going to find the exact length. So do your estimate, and then to find the exact length, we'll go through that in a little bit. Okay, to find the exact length, we're actually going to create a square, and so I'm going to draw my square like this. The easiest thing that I found to do is think about the lengths of the triangle I'm creating here, and I notice that one side has a length of 3 and one side has a length of 1, and so I need to make sure that that's the same going all the way around. And then notice that I have a larger square now, and I can use the methods we've been doing to find the area of the tilted square. So do that and start again when you're ready. Okay, so I found the length of my tilted square to be 10, and how I did it is that the big outer square has an area of 16, that's 4 times 4. And then my triangles, I would have to subtract off a total area of 6. And so that means that the area of the tilted square is 10, which means that the side length is going to be the square root of 10. And that is the exact length of the segment that we are looking for. It is an irrational number, and we're not going to approximate the decimal of that right now. Okay, so in activity 3, Diego says that he thinks that the square root of 3 is approximately, that's what your squiggly equal sign means, approximately 2.5. And so what they've done here with the number line, they actually have 2 number lines creating your grid, and they've created a square with side lengths of 2.5. So you can see that on the grid. Now, if I take 2.5 times 2.5, I get 6.25, which is clearly not an area of 3. Also, I can see that I already have an area of 4 just right there with those 4 whole units. And so 2.5 times 2.5 is not going to be 3. So the square root of 2.5, or square root of 3, excuse me, is not 2.5. So we are going to find a better approximation. So really what we want is to create a square whose area is 3, because then the side lengths would be the square root of 3. And so it might be something more like this, because now I have 1 whole unit for my area, and these 3 pieces put together, it's going to be close to 3 when we put those areas together. And so for number 2, we are going to try to find a number that is close to the square root of 3. On my number line here, I'm going to start with 1.7, and 1.7 times 1.7 is 2.89. Now we want it to be between 2.9 and 3.1, so I need to adjust that a little bit. So I'm going to do 1.72 times 1.72, and I get approximately 2.96. And so that's pretty close. There's other answers you could come up with too, but we could say that the square root of 3 is approximately 1.72. So to wrap up lesson 4, how can you approximate the value of the square root of 130? Yes, you can just use a calculator to get you a decimal approximation, but our goal is to be able to think through these a little bit more deeply. So how can we know, so we know that the square root of 130 is somewhere between 11 and 12, and how could we get more accurate than that? Well, 11 times 11 is 121, and 12 times 12 is 144. And I can see that 130 is going to be a little bit closer to 11 than to 12. And so my estimate would be something like 11.3 because it's going to be a little bit closer to 11 than to 12. Okay, in lesson 5, we're going to be reasoning about square roots and basically approximating square roots. And again, yes, a calculator does it quickly for you, but we want to be able to just estimate them based on what we know about our perfect squares. So again, that perfect square reference sheet is going to be very helpful here. Okay, you're going to decide if each of these is true or false. We'll do the first one together. It's the square root of 5 squared. That means the square root of 5 times the square root of 5. And yes, that is going to equal 5. So number 1 is true. Try the rest on your own and start again when you're ready. Okay, here we go. The second one is false because the square root of 9 times the square root of 9 is 9. The third one is true. The square root of 7 times the square root of 7 is 7. The next one is false because the square root of 10 times the square root of 10 is 10, not 100. And the last one is true because the square root of 16 is 4 and 2 squared is also 4. Okay, the square root of 7, I can see on my number line, it's going to be here somewhere between 2 and 3 because it's going to be between the square root of 4 and the square root of 9. Okay, so I've color-coded these and I've placed them on the number line approximately where they'd be. Number 2 is going to be between 4 and 5, and if you see, it's going to be a lot closer to 5 than to 4. So you're going to want to start thinking about that when you put these on a number line. The square root of 50 is going to be a lot closer to 7 than to 8, and the square root of 98 is going to be a lot closer to 10 than to 9. Knowing which number it's going to be closer to will help you approximate it later on. Okay, so with the perfect squares on your number line, it makes it a lot easier. From these equations, we can see that x is going to equal the square root of 3, which is going to be about right there. Y is going to equal 4 because 4 times 4 equals 16, or in other words, the square root of 16. So that's right there. And z is going to equal the square root of 30, which is going to be really close between 5 and 6, but just a little bit closer to 5. And then number 2, plotting the negative square root of 2. I can see that's going to be about right here on the other side in the negatives. Okay, so to wrap up lesson 5, how can we find the whole numbers that a square root lies between? Use your perfect squares as a guide on your number line or otherwise. How can we get a better approximation? Be thinking about which number is it closer to. And then if you do want to use a calculator to get a more exact answer, if you need one, that would be a good way.